Now the next thing that I want to talk about is trig identity. So we are going to talk about what? The basic trig identity. Identity. Okay. So to talk about trig identity, first we need to understand what an identity is. So an identity is a relationship which is true for all values of the variable. So that's an identity. So let me just write it here. An identity is a relationship which is true for all values of the variable. So you might recall that we have identity in what matrices. We have some in functions also, like identities of some here in functions. Yeah, we have an identity in function where they'll be calling it some e also. Yeah. So we have a lot of like identity, and then what an identity is like, it's just a relationship which is true for what all values, like all values of the what variable. Now we need to talk about what identity matrix. So to oh I was talking about identity matrix. So the basic trig identities, right? So for us to get to that, we need to consider what a circle. So consider a circle of radius r and center 0, comma 0. So when you draw that circle, let me draw the circle first. Let me draw my Cartesian plane. Then this point is the center, which is 0, 0. And any line to what the circle is what r. Now let's consider a point here, which is what x, comma y. And when you draw that, you get something. This here will be what x, and then here will be y. Let me remove that and bring it outside. I'll have my r, my y, and x, and then let me just name this angle theta. From here we will realize that cos theta will be equal to what adjacent, which is what x, over what r, and then sine theta will be equal to what opposite, which is y, over hypotenuse r, and then tan theta will be equal to what adjacent, which is x, over what opposite y. Or is it? It's opposite over adjacent. So is y on x. Yeah. So cancel this out. So y on x. But then from Pythagoras theorem, we know that what the hypotenuse squared is equal to what? Is equal to the opposite squared plus what? The adjacent what? Squared. Right? This from Pythagoras theorem. So we have x squared plus y squared to be equal to what? R squared. If we divide through by what? R squared, we'll get what? X squared over R squared plus y squared over R squared is equal to what? R squared over R squared. And this will be equal to 1 is equal to what? X over y all squared is actually r all squared plus y over r all squared, right? But we know that x over r, which is like x over r here, is equal to what? Cos theta, and y over r is equal to what? Sin theta, right? So 1 will be equal to what? Cos theta squared plus what? Sine theta squared. So then we'll have 1 to be, this can also, you can rewrite it as what? Sine squared theta plus cos squared theta. So this is your first what? Identity, right? Now from r squared is equal to what? X squared plus what? Y squared. We can do more, right? Let's do this. Let's say we have let's divide through by what? X squared. So dividing through by what? X squared. If we divide through by x squared, we'll get what? R squared over what? X squared plus this is equal to x squared over x squared plus y squared over what? X squared. This will be equal to what? R over x all squared to be equal to, this will give us 1 plus what? Y over x all this squared, right? Now let's go and see which of the trig ratios match this. Which of the trig ratios match this? From here we have what? X over what? R. Do you have x over r? We have what? R over x. So that's like inverse. So we have cos theta to be equal to what? X over r. So implying that what? R over what? X will be equal to 1 over what? Cos theta, which is like the inverse trig ratios that we talk about, and which is like sec what? Theta, secant theta. 1 over cos is secant theta, right? Then we'll be having what? Let's go back. We have y over x, right? We have y over x. So we have tan theta to be equal to y over x, and we have y over x here, so we can just substitute that. So then this will now be equal to what? In place of x, r over x, we are going to put what? Sec. So we have sec theta to be equal to 1 plus what? In place of y over x, we are going to put what? Tan theta. Oh, it's actually squared, so let me put the squares there. Then this should give us what? Sec squared theta is equal to 1 plus tan squared theta. So this is our second what? Identity, right? This is our second identity. Now let's move to the third identity. So if you are like, so we'll just take it from what? The same equation again that we derived. So here we are going to divide through by what? Y, right? We are dividing through by y. So r squared over y will be equal to what? X squared over y squared plus what? Y squared over y squared. And this should give us what? R over y all squared to be equal to what? X over y all squared plus what? 1. Now we have to go back to what? The trig ratios that we found, like the trig ratios here. We have y over what? We have r over y, right? We have r over y. So, but we have what? Y over r to be equal to what? Sine theta. Implying that what? R over y will be equal to 1 over what? Sine theta, which we know to be equal to what? Cosecant of what? Theta, right? Then we also have what? Y over what? X. We have tan theta to be equal to y over what? X. But then here we are looking for what? X over y. So x over y will be equal to 1 over what? Tan theta which we know to be equal to what? Cot theta, cotangent. So we are going to substitute this inside into this equation, and then here will give us this first part, and that will give us what? Cosecant theta all squared to be equal to what? Cot theta all squared plus 1. So we have cosecant squared theta to be equal to cot squared theta plus 1. That is what? Our what? Third identity, right? That's our third identity. Now with respect to the fourth identity, let me just do that at this side. So we have tan theta to be equal to what? Y over what? X. What if we divide the numerator and the denominator by what? R. That will give us what? Y over R all over what? X over R, right? Because if we do that, we know that the R can cancel R and we'll get this back. So, but we know that X over what? Y over R is what? Sin theta, and X over R is what? Cos theta. So this will give us what? Sin theta over what? Cos what? Theta. And this is what? Our what? Fourth what? Basic trig identities. Okay, so don't forget these trig identities that we have talked about. So the first one is that what? Sin squared theta plus what? Cos squared theta is equal to what? 1. Then we also got sec squared theta is equal to 1 plus what? Tan squared theta. Then we also had cosec squared theta is equal to cot squared theta plus 1. Then we have tan theta is equal to what? Sin theta all over what? Cos theta. Yeah, so these are the basic trig identities that you should know. Okay, the basic trig identity that you should know. From this, with this trig identity, you'll be able to like solve or simplify other trig expressions. Okay, and there are also like so many applications that we can talk about. So maybe in the next video, I'll be talking about how we can apply these trig identities to actually solving some trig questions.